Namaskar, my dear friends. Let us talk about Zener as voltage regulators. So, as you know, we have Zener circuits, right? So, we have Zener diode, and how does it helps us to, regulate our voltage at the output? That all we are going to see. So, let us say we have a simple circuit with one input voltage, one series resistance, and one load resistance RL. Okay. So this RL resistance can be varied, like our load can be varied always. Understood? So our aim is to understand how this Zener diode with a knee voltage Vz, let us say the clamping voltage Vz, is going to regulate the voltage at output V out. Okay. So to analyze this circuit, what we are going to do is, let us say we remove this. Suppose we remove this guy, then what will happen? we have a simple we have a simple circuit with Rs and RL as series resistances, right? So by voltage division, can we write it down? The voltage across this RL will be equal to V in multiplied by RL divided by Rs plus RL. So this is how VRL is equal to V in into RL by RL plus RL, right? RL plus Rs, right? Now, what will happen in different cases? So let us say this guy will try to clamp this voltage only when this voltage is more than Vz, right? So if my VRL is less than Vz, then this will not come into picture. This will be off. That's the reason I have written Zener is off. That is, no breakdown happens. So Zener works in breakdown, right? So it is not in breakdown. It means my output will be just based on the voltage division principle, and that is going to be my V out is equal to VRL, which is going to be V in times RL by RL plus RS, right? Now next case, let us say my VRL is greater than Vz. Let's say you calculated your VRL voltage across this resistor. VRL you have calculated, which is nothing but your V out in some cases, and in some cases V out will be Vz. Why, I will tell you. So if my VRL is greater than Vz, then what will happen? This Vz will be in breakdown. So I will write it down. My Zener is on. That is, Zener breakdown happened. Okay. And in that case, my V out will become Vz. Understood? So what will be the IL? That is load current. Let us say IL will be how much? So the load current will be in that case Vz by RL, because voltage across this line will be Vz, and similar to that we will have, let us say, current Is in this branch, and that Is current is going to get splitted into Iz plus IL. So for that reason I am going to write my source current is going to be Is is equal to Iz plus IL. Understood? That is load current plus Zener current. Got it? Now let us see little more. We have a provision of how much RL we should keep, so that this is always working as a voltage regulator, right? That's the thing that we have to understand. So what will happen? Let us say if my RL maximum is there, then my IL minimum will be what? The load current minimum will be what? Vz will be on, like Zener diode will be on, divided by RL maximum. Similar to that, if RL minimum is there, then my IL maximum will be, like, maximum current through the load resistance will be how much? That will be Vz divided by RL minimum. Means I am assuming the fact that Zener diode is always on, in such that, like, the resistance value RL is such that the voltage across RL is greater than or equal to Vz. So in both cases we must have VRL is greater than or equal to Vz. Then only Zener diode can be on, right? Now let us say we had this circuit, right? So this is my Zener diode circuit and this is my input voltage. So this is RS, this is RL, and this is, let's say, VZ, and this is my VIN. So can we tell that, let us say, this is my IS and this is my IZ and this is my IL, okay, and this is your V out. So can you tell me that IS was IL plus IZ, right? From here we can write it down. IS is equal to V input minus VZ divided by RS. Why? Because the voltage at this node will be VZ when my Zener diode is on, and it will be possible only when my VRL is greater than or equal to VZ. So in that case, my V input minus VZ divided by RS will be IS, and this is going to be a constant quantity. It means your source current will always be constant irrespective of your value of RL, right? What happens in this case is, if your IS is constant, then what will happen? Basically, the value of IL varies, right? And then IZ will also vary. So these two guys are varying each other, keeping IS constant. Okay. So that is nothing but, it follows, like a principle something like this. Let us say this is my I and this is my V. So IZ will start growing and then it will be in cutoff. So basically this is going to be I max, and this is the place where it will be IZ knee. Okay. So knee current. So if we solve this, we can write it down something like this. My IS is going to be equal to IZ, let us say it is maximum, plus IL minimum. Or it can be written as IS is equal to IZ minimum, which is going to be knee, plus IL maximum. So IL maximum can also be calculated. So this is how you can see that my Zener diode is actually acting as a adjustable current device. Okay. Zener acts as adjustable current device. Understood? And my IZ minimum is nothing but your IZ knee. Okay, that cut in. And IZ maximum, if you want to find out, this will happen only when, if your power rating is given for the Zener diode. So let us say this is your Zener diode. So it will be having VZ and its power rating is PZ. The current that is going to flow is, let us say, IZ. So you can see that what will be the withstanding power of this Zener diode. IZ into VZ, that will be actually PZ. So I can write it down as PZ by VZ. So this is the maximum current that Zener can withstand. That's all. So this was all about Zener circuit that we have seen. Let us take a question so that you can have a good understanding of how to calculate the voltage. So can you tell me whether Zener is off or on in this particular circuit? So let us say we have a Zener diode like this, and we have a resistor, load resistor. So this is how we are going to have. So let us say this is my V out, this is 1 kilo ohm, and the Zener diode voltage is actually 6 volt, and this resistance is 1 kilo ohm, and this input voltage is 10 volt. All right, so what we can do is, if we remove this particular Zener diode for time being, then what will happen? We have RL and we have RS. So what will be the voltage across RL? That is the load resistance. So it is very simple. My VRL is going to be 1 into 10 volt, like resistance RL into input voltage divided by total resistance 1 plus 1. that is going to be 5 volt. And as you can see, my 5 volt is less than 6 volt, that is your VZ. Understood? So this VZ, if it is less 5 volt is less than VZ, then Zener will be off. Zener is off. And if Zener is off, then my output voltage will actually follow a simple voltage division principle, which is going to be VRL, voltage across load resistor, which is going to be 5 volt. That's all. And in that case, if you want to find out what is the load current, okay, so what will be the load current? IL will be nothing but your VRL by RL, that is going to be 5 volt divided by 1 kilo ohm, that is 5 milliampere. And ideally, in that case, the current flowing through Zener diode will be 0 because it is off. Let me give you another question so that you can have a proper understanding. Okay, so let us say the same question, I will take it. Now I am going to change the value of these resistors. Okay, so let us say this is my 2K and this is my 3K. So what will happen? My VRL in this case is going to be 3K, that is 3 multiplied by 10 divided by 3 plus 2, right? So 3 into 10 divided by 2 plus 3. So that is 5 30. So 5 duna 10, 3 duna 6 volt. As you can see, my 6 volt is nothing but your VZ. So it means Vout will still remain 6 volt, not a problem. We cannot tell for sure like Zener will be on or off. It is on the verge. Okay, so try to design a circuit in such a fashion, such a manner that it is not the case, either it is lesser than that or more than that, so that you can be very sure that Zener is on or off. Okay, so in which case Zener will be on, my load resistance voltage must be more than that, right? So let us say I am going to put this resistance as, let us say 8K. Okay, so this case I am going to remove right now, or let's say I will not change this, otherwise you will get confused. Okay, now let us say this is 1K and this is like 4K. So what will happen my VRL? Tell me. 10 multiplied by 4 divided by 1 plus 4. So that is going to be 5 duna 10, 4 duna 8 volt. Can you tell me my 8 volt is greater than VZ, that is your 6 volt? So it means definitely Zener is on. Zener is on. It means what will happen? This guy will clamp the output voltage to Zener voltage. It means my V output will be equal to VZ, that is going to be 6 volt. So assuming that Zener was off, we calculated voltage across load resistance, that is 4 kilo ohm, and which is going to be 8 volt. However, since 8 volt is greater than the knee voltage of Zener diode, we are going to see that the voltage will be clamped to 6 volt, and this 6 volt will be the output voltage of the particular circuit. Understood? And since this is 6 volt, so now in this case, can you tell me what is going to be my IS and what is going to be my IZ and IL, everything? So now it is very clear. My IL is going to be 6 divided by 4K, that is 1.5 milliampere. And my IS will be 10 volt, that is this 10 volt minus VZ. So minus 6 divided by 1K. So that is going to be 10 minus 6, that is 4 by 1, that is 4 milliampere. And what will be my IZ? The current flowing through the Zener diode will be equal to VZ. What is that? You know already, total current was IS minus load current is IL. So that is going to be 4 minus 1.5. So that is 3.5, sorry, 2.5 milliampere. So now you are having very clear idea like how to solve the Zener circuits when it is on. So basically it is going to act as a voltage regulator, that is output will always be regulated to 6 volt, that is clamped to 6 volt. So alright guys, you have a good understanding. Now we will try to give you some simulation circuits so that you can solve very easily how to solve this particular Zener diode circuits. So if you do have any questions regarding like Zener circuits and how to solve them, you can always put down your questions in the comment box and we shall be able to answer you out. Thank you.